I wanted to finish this section on discrete Markov models, i.e. n-gram models, by talking about a really neat application where these are essential for an efficient text entry system called Dasher. This is a system that was originally designed by David Mackay and colleagues at the University of Cambridge. And the goal is to provide a great, efficient way of interacting with a computer and entering text for people with disabilities. So for instance, those that have movement problems, so they can't use a standard keyboard, perhaps they're able to use eye movements, or maybe in severe cases, a breath input device, whereby if you control your breathing, you have a band around you which controls, that measures how much you're exhaling or inhaling, and you use that to control a cursor. So we're going to show you an example of that system now, where a user is going to type the following sentence into the system. The sentences they're going to type says, "This is how to type with Dasher." It takes some practice, but you can be very fast with time. Okay, so let's just see how that works here, and I'll pause the video as we go through. So we start off by moving a cursor around, and the cursor is shown by the arrow in the middle of the yellow box. And if you move the cursor to the right, then you start to see the alphabet on the right hand side with A's at the top going through to S at the bottom here. And that's showing you your goal is to look up in that alphabet the first word of your sentence. So we're going to look up the first word of the sentence shown on the previous slide here. So we go down the bottom and we're looking for the T of this. And so we found the T here, and we're going to move our cursor inside the box. And when that T crosses the center line here, you can see in the top left-hand corner of the screen that we have typed the letter T. And the next letter we want to type is H, and you can again see actually all possible things that you want to type laid out on the right hand side, and H is rather bigger than the others, and so we just go across the H and write H. So what's going on here is that we fitted an n-gram model, actually a trigram model I think in this case, to the documents written by this individual, so their emails and maybe their word processing documents, their LaTeX if they use LaTeX, and we have figured out from that model what the probability of the next character in the sequence is given the previous ones based on their historical writing. And so at this point where we have typed T and H, the boxes which appear next are proportional to how likely that next token is in the sequence. So you can see E is really, really likely and takes up a big area, but I is also likely, the next most likely letter, and so that takes up the second largest area, and that means it's really efficient to navigate towards it because you don't have to navigate very far or very precisely. And then inside that letter are all possible tokens that might follow that one, and so S is really, really likely to follow I, because this is a very popular word, and his and is are all popular words. So that has high probability under the model too. And that makes it easy to type S of this. And then finally, after S, you can see that the space character, the white character, is by far the most likely. This is designated or shown by an empty box. And so we can very quickly type this, and then is follows. And then you can see how here. So you can see in this way, by just fairly minimal control of the cursor, we can write out the whole sentence in this efficient way. And you can spend sort of hours typing things in this manner, seeing what emerges. So we've almost completed our sentence now, at least the first part of it. We've got this is how to type with, and then we're looking for Dasher. And what happens here is that the controller has gone into D, and actually you might worry what happens if you make a mistake, and here we have made a mistake. We've got a lowercase d rather than an uppercase D, so we need to back off and find the uppercase D's, and the uppercase letters are actually all towards the bottom here. Perhaps didn't spot this before, but uppercase and lowercase letters are all included in this pane here. They're in the yellow box, and so we can go in here and find Dasher. So you can undo things by just going backwards, and exclamation points and things like that are also in here. So that's how the system works. It's super efficient. It uses this idea of having boxes which are proportional to the probability of each next token in the sequence, which are themselves driven by a trained n-gram model on the user's documents. This is very, very closely related to the idea of arithmetic coding from information theory. So if you want to read more about that, David Mackay's textbook or resources are online are a very interesting read. Next, we're going to look at continuous valued Markov models.